Physics? It's a language. What's wrong with you? Yeah, it's a language we invented to describe nature. It's our best way to describe the world we live in. Physics always goes hand in hand with math. Math is like the grammar of this language. And I know that just hearing about grammar your head starts spinning, but keep it still for a moment. Think about it. What's the point of grammar? Grammar brings everyone together. It allows us to communicate with clear rules. Otherwise, everyone would just speak their own language and nobody would be able to understand anything. Same story for physics. Without math, it becomes pointless. So, sorry, you have to do math. If you can't solve an equation, you just can't solve a physics problem. When someone talks about black holes on your Instagram feed, they're not giving you a real physics lesson. They're translating physics concepts into understandable language. They are actually removing the harder part, which is precisely math and formulas. Physics, being a language, has its own words, and physics words are called physical quantities. What's a physical quantity? It's a characteristic, a property of an object or a phenomenon that you can measure. It is something you can associate a value to. But let's be clear, the F- on your last physics test is not a physical quantity because, yeah, it has a value, but it's there to measure your ability in that subject and maybe your desire to study, which are just no physical properties of anything. On the other hand, the painful time you will spend studying if you don't follow this channel is a measurable physical quantity, so please subscribe and watch the other lessons. Physical quantities can be, for example, your height, your coffee temperature, or pasta cooking time. On the contrary, your happiness, your desire to live, and your immense love for us are not physical quantities. Now that we have clarified what a physical quantity actually is, the problem is that a little while ago I told you something very important and you just didn't realize. I talked about measure. In physics, measure has a very specific meaning. Let's think about this example. When you measure your height, you are actually comparing your height, which is the quantity you want to measure, to a length of reference, which are the centimeters of your meter. So, if you tell me, I am 170 centimeters tall, you're saying your height is 170 times the reference unit you have chosen, which is the centimeter. This unit of reference is called unit of measurement. Each value of a physical quantity must have its own unit of reference. For 170, centimeters are the unit of measurement. But if you take it off, it just goes nuts. Hey, how tall are you? Well, 30. 30 what? Meters? Tomatoes? Cods? In summary, in physics, measuring means comparing to a reference. But be careful, you can't just come up with your own units of measurement. Cods are not allowed as a unit of measurement for length. Only some specific units of measurement can be used in physics, and they are those imposed by the International System of Units of Measurement. The International System is a convention that almost the whole world adopts to choose the unit of measurement for each physical quantity. According to the International System, there are 7 fundamental quantities, which are just like primary colors. Every other quantity in nature is derived from these 7. Each fundamental quantity also has its own fundamental unit of measurement. Now let's dive a little bit into these 7 quantities, although the first 3 are the ones we have the most interest in. Number 1. Length. It is measured in meters. It is defined as the distance between 2 points in space. Number 2. Time, which is measured in seconds. What time actually is, it's quite difficult to explain, so we won't waste time with it here. For now, you just need to know that time is a dimension of the universe we live in, so it's something we are constantly moving through. Number 3. Mass, measured in kilograms. We all think of mass as the scale stuff and we easily confuse it with weight, but it's a little more complicated than that. Mass is a property of your body related to your resistance to movement. Number 4. Temperature, measured in kelvins. Number 5. Electric current, measured in amperes. Number 6. The amount of substance, measured in moles. Number 7. Luminous intensity, measured in candelas. Every other possible unit of measurement you can think about can be derived from these 7 ones. To give you an example, in physics, forces are measured in newtons, which according to the International System are equivalent to kilograms per meters over seconds squared. Sometimes, using only these 7 units of measurement can be quite awkward. If I had to count my spaghetti cooking time in seconds, I would spend 10 minutes with my stopwatch in hand just to get a perfect measurement. Also, I dare you to ask your barber for a 0.00006 kilometers haircut. Thank goodness there are multiples and submultiples of units of measurement. Those are units of measurement larger or smaller than the basic ones, and more convenient on a practical level. It's like saying that red is a primary color, but there are different intensities and gradations of red. So you use centimeters for your hair, while pasta cooking time is measured in... Now let's have a look at which units of measurement are the most useful and the most used multiples and submultiples with the help of this diagram. Let's take meter as our starting unit of measurement. If you use seconds, kilograms, kelvins, it's always the same. Going one step up on this diagram means multiplying by 10. Going one step down means dividing by 10. So, 10 meters is called a decameter, dA. 10 to the second, that is 100 meters, is called a hectometer, h. 10 to the power of 3, that is 1000 meters, is called a kilometer, k. 10 to the power of 6 is called a megameter, capital M. 10 to the power of 9 is called a gigameter, capital G. 10 to the power of 12 is called a terameter, capital T. Now let's go downwards instead, starting with a decimeter, that is 10 to the minus 1 meters, D. 10 to the minus 2 is called the centimeter, C. 10 to the minus 3 is called a millimeter, M. 10 to the minus 6 is called a micrometer, with the Greek letter mi. 10 to the minus 9 is a nanometer, N. 10 to the minus 12 is a picometer, P. 10 to the minus 15 is a femtometer, F. It takes some time to get used to all these powers of 10 and all these symbols. Be careful, because in physics problems often turn out wrong, not because you didn't know what to do, but because you just messed up with these things. So do a lot of practice. Okay, let's say it straight away. You cannot add together two quantities with different units of measurement. It's illegal, forbidden, immoral. Hey, how long have you been on vacation? Well, 7 days and 5 liters. I'm gonna choke your hamster. You got the point. Sometimes this can be solved, but just if one of the two quantities is a multiple or a submultiple of the other one. How long have you been playing Borderlands non-stop? Well, 2 weeks and 3 days? Okay, in this case, I can just convert weeks into days and then I can easily sum them and get 17. But if I don't do this first, I can't just do 2 weeks plus 3 days equals 5 days or 5 weeks. So please, when you do your calculations, do not add centimeters to meters or grams to kilograms, otherwise I will find you. For now, subscribe and turn on the notifications. If you want, you can support us with a tip. You really help us create more content. Also, visit us on Instagram and TikTok and take a look at the other lessons too. See you next time. Ciao!